Well, I received my PhD in 1982 in geophysical sciences from the University of Chicago. And I spent my entire career in academia, with jobs at the University of Wisconsin-Madison, Purdue University, Penn State University, University of Colorado Boulder, and most recently at the Georgia Institute of Technology. And at Georgia Tech, I served as chair of the School of Earth and Atmospheric Sciences for 13 years. I've written several books and published about 190 journal articles. I'm a fellow of several major professional societies, have received some recognition for my research. I left my university position in 2017. I felt it was too constraining. I wanted to do a broader range of things, and I had started a company about 10 years before. It was a startup under Georgia Tech's Venture Lab program, and so then I started devoting full time to it after I left academia. I inadvertently stepped into the limelight on the global warming issue in 2005. If you recall, at the time of Hurricane Katrina, which devastated New Orleans, I and my co-authors had a paper that was published in the journal Science 2 weeks after Katrina hit. And we had found that the percentage of Category 4 and 5 hurricanes had doubled in recent decades. Okay, and so this was met with rather explosive media attention. And this was, the first time, that I did TV interviews or anything like that. And it was a very antagonistic debate. People were coming at us from all sides. Of course, the enviro advocacy groups thought, I was the greatest thing since sliced bread, but there were a lot of people on the other side of the debate, thought I was absolutely evil. So for the first time, I started, giving a lot of public lectures, and people would invariably ask me questions that were, outside of my expertise or knowledge. Everyone was asking about the hockey stick, for example, or what's going on with the sun, and all these kind of things. I figured, oh my gosh, I really need to just step out beyond my personal areas of expertise and try to understand a lot more of this, so which I did. And eventually the hurricane and global warming issues settled down a little bit. And then a few years later, ClimateGate struck. This was in November of 2009 with the unauthorized release of emails from the University of East Anglia, IPCC authors, hiding the decline, Mike's nature trick, all this kind of stuff. And I took the controversial, step of saying, we need to do better. We need to make all of our data publicly available. We need to make our methods transparent. We need to pay more attention to uncertainty and be more honest about the level of confidence we actually have in this stuff. And we also need to pay attention to skeptics, and treat them with respect and, pay attention to their arguments and refute them if they're serious. And, to me, this sounded like motherhood and Apple. But the people within the climate community were very angry at me, saying that I needed to be more sensitive to the feelings of these scientists who were involved. I said, excuse me, no one was sensitive to my feelings during the hurricane and global warming wars. And also, I wasn't worried about their feelings. I was worried about the IPCC and the credibility of it, and what we should be doing about this. There were much bigger issues at stake here. First off, there were lots of pot shots thrown at us. Okay, the couple of criticisms turned out to be valid. One is that the global data before 1985 is pretty dodgy. We went back to 1970, so realistically you have to throw out 15 years. And the other thing was looking at, just the natural variability, and could we really distinguish a warming signal from the natural variability? And at this point, we still can't with a lot of confidence. People outside the clique of establishment climate scientists thought this was great, this is important, this is obvious. However, within the clique, they viewed me as trying to destroy a consensus that they had been trying to build for 20 years. Well, this was a manufactured consensus, and it was on very flimsy ground. A good assessment at the time. And then the powers that be says we need to strive for consensus in our statements. And so this sort of narrowed the framing, and the people they were picking to be on the committee were people who were all going to agree. And so they were working to manufacture a consensus. It was their view of how the policy process deals with uncertainty. So it was sort of a speaking consensus to power approach. And this was formalized by the IPCC. And, people challenging the consensus, and there's many dimensions to it, but the most fundamental one is that most of the warming that we've seen since 1950 is caused by to deal with dangerous anthropogenic climate change. Again, this was a 1992 treaty before we even had any evidence of human-caused warming at all. Okay, and then you had scientists become invested in this, in their career goals and the funding that comes into the field and all of this kind of stuff. There was this sort of social contract between the scientists and the policymakers that perpetuated this situation. And, and they were, the policymakers, we need, more, we need more and more confident statements from the IPCC, even though the dimensions of the problem were growing and growing and growing every year, and clearly becoming more complex and obvious that there were a lot of things that we didn't understand. But there was this drive, until recently, people were looking at projections of 4 to 5 degrees centigrade more warming over the course of the 21st century. Okay, the issue was wildly ridiculous emissions projections, which are now believed to be implausible. The more recent IPCC assessment report with more plausible emissions scenarios is looking at more 2 to 3 degrees centigrade of warming. And we've already had 1 degree, so it's an additional 1 to 2 degrees centigrade of warming that people expect based on the climate models. So they were pretty alarming up until recently, because everyone was focused on this extreme emissions scenario, which is now widely accepted as implausible, if not impossible. So there was a lot of alarm, and all the, when you talk about all the projections of extreme weather events, and we won't be able to grow wine in California, and crazy projections of sea level rise, all these projections were tied to that extreme emissions scenario. And it's taken the community a long time to reject it. In fact, this extreme emissions scenario was still the most widely used in the 6th assessment report, which was published only 2 years ago. So, I mean, this is still pervasive, these excessively alarming projections of what could happen in the 21st century, mostly driven by implausible to impossible emission scenario, but also driven by climate models that are running too hot. The net result of these uncertainties in water vapor and cloud feedback is that we don't know how sensitive the climate is to increasing CO2, because the way the models treat it is that CO2 and clouds amplify the warming. and I think the cloud feedback might even be negative. Water vapor does overall amplify the warming, but in the tropics, where Richard Lindzen has done his research, he proposes that there is a negative feedback, and that's something that's hotly debated. But I think the clouds are the bigger issue. But apart from what's going on in the atmosphere, to me, it's really the oceans and the sun that are the biggest sources of uncertainty in terms of understanding what's going on and be able to project into the future. So there are...
Okay, why the oceans?
Oh my goodness. Okay, the oceans have these large circulation systems overturning. Okay, the El Nino, La Nina, people are familiar with that. That's a mode of natural internal variability. There's also decadal and multi-decadal oscillations cycles that change the patterns of clouds, the whole patterns of sea surface temperature, influence the snowfall on Greenland, the Arctic sea ice, rainfall, regional climates, etc. And the models don't treat these very good. Well, there's a whole spectrum of these ocean circulations all on out to 10,000 years. You have millennial scale overturning that influences the climate, and the models have far too little power. But more fundamentally, these large-scale, they change the weather patterns and change the clouds, among other things. So, this is trying to get all that modeled right, let alone making credible predictions into the future. We're not there. I mean, not even close to being there. Okay, and then once you get into the sun, it's even, crazier. I mean, the IPCC has pretty much dismissed the role of the sun, in the last 150 years. But the interesting thing is that in the Sixth Assessment Report, Chapter 6, they finally acknowledged the great uncertainty in the amount of solar forcing in the late 20th century. And this arises from, there was a gap in the satellites measuring the sun output that occur at the time of the Challenger shuttle disaster, if you recall that. And so one solar sensor was running out, and they were supposed to launch another one, but all the launches were put off for a number of years until they sorted out what was going on at NASA with the launches and everything. So there's this so-called gap, and depending on what was actually happening in that gap, you can tune the solar variability to high variability or low variability. So all the climate models are being run with low solar variability forcing, but for the first time, Chapter 2 in the observational chapter of the Sixth Assessment Report acknowledged this issue, that there is huge amount of variability. And this doesn't even factor in the so-called solar indirect effects in terms of, there's a lot of, it's not just the heat from the sun, there's a lot of issues related to ultraviolet and stratosphere and cosmic rays and magnetic fields and all these other things that really aren't being factored in. They're at the forefront of research, but they're certainly not factored into the climate models. So there are so many uncertainties out there that affect certainly the projections of what might happen in the 21st century, but also our interpretation of what's been going on with the climate for the last 100 years ago and exactly what's been causing what. The weakest part of their argument is whether all this is dangerous. The sea level rise is, creeping up. The ice cap, Greenland, Antarctic, it changes from year to year with a little bit of melting, but there's no catastrophe looming on those fronts, and so they've turned to extreme weather. Global warming is calling, and I have to say the hurricane and global warming first put this idea into their head. If we can show that even 1 degree can cause something bad like more Category 5 hurricanes, then we have something. So this started this whole trend of every extreme weather event is associated with human-caused global warming, which just isn't true.
Right.
And if you look back, and they tend to go back to 1970 or 1950. Oh, this is the warmest year, the worst storm, or the biggest drought, or whatever since 1970, maybe since 1950. But if you look in to the first half of the 20th century, the weather was way worse, certainly in North America and over much of the globe also. Right now in the U.S. West, we're being assaulted by these atmospheric river events, bringing huge amounts of rain and snow, which is going to cause flooding. It's still snow yet. And, this is horrible, global warming and everything like that. But if you go back to the winter of 1861 and 1862, 15 inches of rain fell in central California over a period of a couple of months, which huge floods over a very widespread area that lasted for absolute months. Okay, and paleoclimate evidence showed that these tend to happen about every 200 years or so, where you have this massive accumulation of these atmospheric rivers. So this is nothing at all unusual. So if you look back into the historical record, or better yet, the record, invariably you will find worse weather events. So, to some extent, it's true. There is one sort of tipping point that we could encounter. And if this does happen, I would expect that human-caused global warming would play only a small part. And this is the West Antarctic ice sheet, which is an unstable ice sheet. So if you took the ice sheet away, the continent would actually be underwater. But what it is, you have this huge ice sheet that sits on the continent, and part of it's above water, okay? And it has an overhang. And and this is just a dynamically unstable situation, and it moves fairly fast. Underneath this ice sheet are lots of inactive volcanoes, even the occasional active volcano. So if these volcanoes became active and we had, a greater heat source under this, combined with sea level rise and a little bit of global warming, this could accelerate. And on the time scale of, 3 or 4 centuries, we could see this collapse, which could lead to a substantial sea level rise. So that's the one kind of, if we saw that happening, are there engineering ways of dealing with it? I don't know, but it was something that would be a slow process. But that's the only one of the so-called tipping points that I see could happen, because if there's going to be some solid Earth, if the Earth wants to have an earthquake or a big volcanic eruption, there aren't a lot of negative feedbacks in the Earth system to prevent that. So to me, that's the one bad thing that could happen, but it would take centuries. But the other ones, I don't see it. Well, the interesting thing is that the IPCC's Sixth Assessment Report, Working Group 1, they also sort of rejected the climate models to some extent. They were guided by them in their projections, but they also, defined a plausible range of climate sensitivity and looked at the projections from there. So even the IPCC is stepping back from the global climate models as being useful for projections. And people are going to these climate emulators, these simple climate models. Well, for this amount of warming, run it through a damage model or an economic assessment model or something like that. So people are really stepping back from these big global climate models, and it's about time. And one of the innovations that I've been undertaking in my projection work, and this is what I do for clients of my company, Climate Forecast Applications Network, is that I look at it. I don't just look at the IPCC scenarios, and I choose the low-end ones because I think those are more credible, but I also look at scenarios of what the ocean circulations could be doing, scenarios of volcanic eruptions, and solar variation scenarios, and try to put forward a broader range of what we might be looking at. And so I have like a network-based approach to combine all this into producing a much broader range of scenarios. And at least over the next 3 decades, like the natural variability piece of this is pointing towards cooling rather than amplifying the warming. It would tamp down the global warming of whatever magnitude it is from fossil fuel emissions. So that's the approach that I'm taking. A big issue is a potential shift to the cold phase of the Atlantic multidecadal oscillation. This is one of those multidecadal oscillations that I talked about, which we would expect would start to tamp down the Atlantic hurricane activity. So this is a very big deal for them. Another client was wind farm owners who wanted to know, is the wind going to keep blowing for the next 30 years, and are my wind farms in the right location? Okay, they wanted to know that. Some electric utilities want to know, what could we be looking at in terms of like how frequent these really bad situations could be, for renewable power, like a massive cold air outbreak that lasts for weeks, the wind doesn't blow, and it's wintertime and there's no sun. How bad can it get, and how frequently might these occur? So these are some of the things that I've been looking at. And also people interested in sea level rise projections, in their particular location, looking at scenarios of what their location. A lot of interest from people in Florida, San Francisco, along the Atlantic coast. What could we be looking at? Yeah, we see that those projections from the IPCC. Which of those should we believe? But we already know that, how are the ocean circulation patterns going to influence their local sea level rise? What kind of trends do I see for the vertical land motion, both from local effects and large, more planetary scale up and down kind of effects? So those are some of the projects that I've been working on, looking at scenarios out, say, 30 to 50 years. Okay, the first thing that I did, and I did this before most other people did, I say, look, you're wasting your time looking at that extreme emissions scenario. If you look at the International Energy Agency, their scenarios show emissions being fairly flat for the next several decades. And I think this is a much more plausible scenario. So let's focus on that one. And this is apart from trying to predict what policy's going to do and how much they're going to change, but the thinking is now that emissions are going to stay fairly flat for the next few decades. And I saw this, and I saw the journal publications, and this is what I was pushing to my clients. If you want something realistic, this is what you should be looking at. The other thing is not accepting the extremely high values of climate sensitivity to CO2 doubling. I don't go as low as Richard Lindzen does, but I'm certainly on the low end, and I justify why, to them, based on publications, including some of my own, why we shouldn't be looking at these very high sensitivity values. And I run it through a range so they can look, but I'm saying, so I give them all the scenarios they want. I'll give the high emission scenario, I'll give the high climate sensitivity, low climate sensitivity. I'll say my best judgment is that this is what it is. But then I uniquely put in scenarios of the natural variability. Okay, well, I don't say it's first they neglect all the elements of natural variability that I conclude. They're not giving scenarios of volcanic eruptions. They're not giving different scenarios of sun activity. They don't have, they have a bunch of different scenarios of what the internal ocean variability is doing, but I can anchor it more closely to what the observations are and my own network model in terms of what the plausible trajectories are. So I'm giving them a more plausible trajectory for the ocean oscillations. And generally, going out 30 years, these other scenarios are cooler than the IPCC scenarios. And there have been a number of publications, you never see them publicized, that show for certain combinations of these ocean circulations or volcanic eruptions or solar activity that you could see cooling for a decade or two during the 21st century. That could happen. And the IPCC AR6 did, if you read the fine print deep in the chapters, you'll see these papers referenced and it is acknowledged. But it's not something that you hear, in the public debate. It's just this relentless warming that we're going. In the 1980s, the UN Environmental Program, was looking for something. We hate capitalism. We don't like the oil companies. We like world government, all this kind of thing. And they latched on to the climate change, the CO2 global warming is what it was called back then, and this seeded, the formation of the UN Framework Convention on Climate Change, and there was a treaty signed by 192 nations in 1992, including the U.S. Okay, this was before we knew anything. We had to avoid dangerous anthropogenic climate change before we had any idea of any of this, and so this framed the climate problem in a very narrow frame. All of climate is now caused by CO2, and by definition, warming is dangerous. It wasn't really until the Paris Agreement that they came up with, this more voluntary thing. And then they started phrasing it. And there was a spate of, bad weather, big El Nino and stuff like that they latched onto. This extreme, if we just got rid of all this, the weather would be nicer. We'd get rid of all these floods and droughts and hurricanes and whatever else and heat waves that was plaguing humanity. And so people bought that kind of simple argument. And then once there was a real shift in 2018, after the Paris Agreement, the rhetoric was, climate crisis, climate emergency from the world leaders, the UN, President Obama, Macron, Merkel, all of these leaders saying this. But in 2018, people started paying attention. And this is when Greta Thunberg came onto the scene. And she's a remarkable person. She's wrong a lot of things, but a remarkable person nevertheless. But what she was doing spawned the Sunrise Movement, Extinction Rebellion, all this kind of stuff. And the journalists amplified this, the climate crisis, the climate emergency. 10 years ago, climate change was like really a fringe topic at journals. Now major media outlets have a climate desk. I have a whole team of journalists, and there's huge money going into things like Carbon Brief, things that focus specifically on climate change. And so it's just exploded. And again, there's this social contract between the policymakers, the media, and the scientists. It's great for the science. There's nobody. 10 years ago, people with a PhD in climate science, would be trying to get a postdoc and whatever. And now the universities can't even hang on to them. There's so many jobs in the media and the private sector that, this is just a hot thing. Every university now has some sort of climate-y department, institute. It's just big business for everybody. And so there's this mutual reinforcement. Let me tell you what my sin was. People don't object to my science. I mean, I'm within, the likely range of the IPCC for the most part, on the low end. But, it's not fringe perspectives. And I commonly cite the IPCC. what happened, the reason I was shuffled off into denier camp is because I criticized the behavior of climate scientists. I criticized the IPCC for some ethical violations as well as not paying enough attention to uncertainty. So that was my sin. Okay, I offended and criticized the grand poobahs of the climate community. Okay, if you go back to 2001, this was the release of the third assessment report from the IPCC. And Sir John Houghton, who was the head of the IPCC, was giving the press release. And the backdrop behind him was this image, a curve that looked like a hockey stick, which was meant to portray that, the climate was very stable for the last 1,000 years, and all of a sudden you've got this big uptick, that is caused by humans. Well, but the issues of the hockey stick were not so much that. The trigger, the hockey stick trigger, important one, is around 2000. Right after that, this was viewed by a mining engineer, Steve McIntyre. He said, hockey stick, I've seen these things. This is usually a con game trying to get somebody to buy mining stocks. He says, then he got intrigued. He wanted to look at the data. So he asked for the data. They gave him some of it. And he and Ross McKittrick, Canadian economics professor, took a look at this, and they found all sorts of errors, mishandling of data, inappropriate statistical methods, on and on it goes. And man went after these guys big time rather than, constructively trying to deal with these criticisms. He went after these guys, and this turned into a pretty big flame war. And then McIntyre and McKittrick published 2 additional papers in 2005, and the controversy, was just explosive. There were congressional hearings on this, and on it went. So it was this huge controversy, and these ClimateGate emails that were released in 2009 revealed all sorts of paleoclimate record, just, showed these little oscillations, and to get that sort of hockey stick piece, they spliced on the observational record on top of that, okay? And it wasn't clear in the IPCC report that was done. It was sort of in some sort of a footnote or an obscure reference. Went into their analysis, it was just like the flat handle. In order to get the blade, the uptick of the blade, they spliced on the historical temperature record, completely different. This is the so-called hide the decline. And so, to me, this is something, without doing that is a bad idea, but doing that without explaining it is marginal. And this is known in some circles, subsequently would be given a label as image fraud. And so this is what I wrote my blog post about, and I wasn't particularly attacking man because he wasn't the only person involved in this little deception. But, this got a lot of attention, and apparently Michael Mann was unhappy. And pretty soon after that, he was calling me denier on Twitter, and then I started appearing on all these misinformer lists. And by 2012, I was firmly established as a denier. And the Society of Environmental Journalists put together a list, a description of all the climate blogs. And my blog was under the list of denier blogs. And the description says, unlike most other denier blogs, Curry is a real scientist. She looks at both sides of the issues, digs deep into the issues, discusses the uncertainties and all this other stuff. And I said, well, that's a beautiful description of my blog, but why did they accept prima facie that my blog is a denier blog? I mean, it just shows how pervasive and how stupid this whole thing was. So I got tossed into the denier camp. I don't align myself with either side. I've preciously fought for my independence, which included resigning my academic position. So, I think for myself, I think deep, I look at the evidence, make judgments, and it's mostly about trying to better characterize uncertainties in what we don't know. This is a key part of rational policymaking, is to understand the uncertainties in what we don't know. I mean, if we were to immediately stop emitting fossil fuels, we probably wouldn't notice any change in the weather, throughout the rest of the 21st century. So this is the key error in logic that people have been made. Well, I mean, it's not an error in logic. It's a very effective selling point for the alarmists, but people have bought it. And people have weather amnesia. I mean, if you just look back to the 50s, to the 1950s, to the 1930s or whatever, the weather was much worse, certainly in North America. So it's just something that doesn't make sense. Does that mean we should just keep amping up the fossil fuel emissions? No, we just really don't quite understand the consequences of this, but neither does it imply that we should urgently reduce emissions and disrupt the global energy systems that will make people less off and less well off and more vulnerable to whatever extreme weather and climate events might happen to occur. So we're hurting ourselves. We're not doing much in the way of reducing emissions anyways, and we're just making ourselves less prosperous and more vulnerable. The thing that, the UN has the 17 sustainability goals. I think the first one is to eliminate poverty. The second one is to eliminate hunger. Maybe number 7 is affordable energy for all. And then number 13 is climate action. And you've got to wonder, how did climate action, even one piece of that, which is, elimination of fossil fuels, come to trump elimination of poverty and elimination of hunger? Well, leaders in Africa are quite outspoken. They're on the front lines of being the victims of all this. They refer to green colonialism, energy apartheid, that they're facing over this global warming policies.
Right.
And they can't get loans from development banks to build. They have plenty of natural gas, coal, a lot of fossil fuel resources in Africa. They can't get loans to build their own power plants. The only thing that they're able to do is sell their fuel to Europe. Yeah, the irony is that even if the African nations were given, the carbon credits or whatever and allowed to develop to where they want to be and where anyone expects them to be, at most, they would be emitting like 5 or 6% of global emissions. And this is for like 1 billion people in the population. So we're not talking about a lot of extra emissions to allow them to develop. I mean, it just makes absolutely no sense. And it's evil. It's absolutely evil. After Lomborg, early on, 2003, whatever, following his book, The Skeptical Environmentalist. And the issue was that he didn't regard, the reduction of fossil fuel emissions as the be-all and end-all. That there were more important things to do. And for that, he got labeled, that was a very dangerous perspective because they were just so set on this one particular policy. For reasons, for poorly justified reasons, and for reasons that became harder to justify as time went on. And they're still stuck on this. And it just defies logic, and it's going to cause a lot of damage in the world.